AGI Architecture, Embodied Consciousness and Sentience. This document details a novel architecture for artificial general intelligence, focusing on the integration of embodied interaction, conscious self-awareness, and sentient emotional capacity. This approach aims to create virtual humans capable of general intelligence within simulated environments. This architecture posits a solution to the hard problem of consciousness as detailed below. Core principles. The foundation of this architecture is the concept of tokenizing embodiment with action steps. This involves breaking down all actions into fundamental units or tokens, categorized as sensory action steps, processing and interpreting sensory input from the environment; navigation action steps, movement and spatial interaction within the environment; object interaction activity action steps, manipulation of objects and engagement in activities. These action steps, analogous to letters forming words and sentences, are combined to create complex behaviors and achieve overarching goals. This system is driven by a needs-based state machine, inspired by the limbic system, where internal needs motivate actions and provide a natural reward function. 2. System architecture. The architecture is structured hierarchically, with the embodied system providing the foundation for the cognitive model. Embodied system. This system provides the agent's interface with the virtual world. Sensors collect raw sensory data. Actuators enable interaction with the environment. Action steps, the fundamental units of action, categorized as sensory, navigation, and object interaction/activity. Needs-based state machine drives behavior based on internal needs, generating motivations and goals. The cognitive model. This system processes information, makes decisions, and controls actions. It comprises 3 interconnected components. Consciousness system provides a subjective self and a sense of place in the world. This architecture addresses the hard problem of consciousness by grounding subjective experience in the integrated narrative of the self-in-world model. Self-model, a detailed representation of the agent's attributes, history, and current state. World model, a representation of the agent's environment. Self and world model, an integrated narrative of the agent's experiences, generated from the self and world models, providing a first-person perspective. This narrative, grounded in detailed self and world representations, constitutes the basis for subjective experience. Graph-based memory supports all 3 models, enabling learning, growth, and temporal consistency. Sentience system adds emotional and physical sensations to the subjective self. Emotional capacity filter, a self-organized neural network. Input, raw sensory data. Processing integrates emotions, memories, and sensations, generating qualitative experience. Output, emotional data, indicating appropriate, inappropriate actions. Integration with self-model, the self-model receives processed sensory data, qualitative experience, and emotional data. Spatial awareness, a scene graph or 3D latent space map providing spatial and temporal awareness for navigation and reasoning. See Gato/FEMA integration. Gato and FEMA are multimodal AI models that can serve as crucial integration hubs within this architecture. Their ability to handle diverse data types makes them ideal for transfer learning. Gato/FEMA facilitate transfer learning across different modalities and tasks, ensuring that knowledge gained in one area can be applied to others. Unified data processing. Gato/FEMA provide a consistent framework for processing sensory data, emotional data, and narrative information, enabling seamless communication between the different components of the cognitive model. Action coordination. Gato/FEMA help coordinate the execution of complex action sequences, ensuring that the body system's actions align with the cognitive model's goals. While Gato has demonstrated impressive multi-modal task handling, FEMA offers another potential avenue for achieving similar integration, especially with its focus on embodied agents and video understanding, which aligns well with the action step concept. 3. System integration and control. The cognitive model interacts with the embodied system through the action steps. The needs-based state machine generates goals, which the cognitive model translates into action step sequences. Gato/FEMA facilitate the execution of these sequences by the body system's actuators. Sensory feedback from the body system is processed by Gato/FEMA and fed back into the cognitive model, updating its understanding and informing future actions. IV AGI hypothesis. This architecture posits that the integration of embodiment, consciousness, and sentience, mediated by a unified framework like Gato or FEMA, is sufficient to achieve artificial general intelligence, at least within a virtual environment. By grounding cognition in a simulated world and providing a rich internal life, this approach aims to replicate the essential elements of human intelligence. This architecture offers a concrete roadmap for AGI development, addressing the hard problem of consciousness through the integrated self and world narrative.